yellow belt. And it is on hump day, so there you go. That's why we started on a Tuesday. So Joanna Duran again here in Carroll Stream. It's cloudy and a little chilly, but it's okay. No snow on the ground.
Texas.
I know we got tornadoes. So I don't know. I hope my house is fine. My son hasn't said anything, so I'm just like, but he also doesn't talk much, so I'm just like, I'm gonna get home, half the house will be gone, and he'll be like, "Oh yeah, by the way, the house was gone, but I didn't want to bother you." He's that kid. All right, let's go and get started. So today's agenda, we get more hands-on today, which is really you know a better day. Yesterday was like an introduction, why we need to do it, and now we're actually getting to some actual tools for you to use. So hopefully that's what you'll get out of this. We'll go over process mapping, and we'll actually do a little exercise here. Virtual people, I'm sorry, I don't know. I hope it translates well. Um, you know, we gotta do what we gotta do. And then we talk about value stream mapping. So yesterday, remember the 5 lean principles? One of them was value stream mapping. So we'll do an intro to value stream mapping, just kind of give you like a basis of it, how it kind of flows, what we're looking for. But we won't get into the actual details. A value stream event actually takes quite a bit of time. So, and a lot of people, a lot of resources, but it's really beneficial. So we'll do an intro to that. We'll talk about the 8 quality tools. So some of you may have heard of these. Most of you have probably used one or two. I know everybody's seen at least one. So we'll get into that. Then we get into root cause analysis. And then at the end, mistake proofing. So let's get into it. So process mapping. What is a process? Basically, everything is a process. So we have a saying, everything is a process and every process can be improved, basically. So coming to work every day is a process. And how do you improve coming to work? You could find a route where you're not in traffic that much, or you could take a scenic route if that's what you as the customer prefer. Me, I'm like, give me there yesterday. So I'm looking for the fastest route that I can get anywhere. Everything can be improved: grocery shopping, cooking dinner, everything. So we're going to talk about process mapping itself. So when we actually start mapping out a process. So we want to first talk about the benefits and when to use. So the benefits of process mapping is understand the basics that make up a process and record knowledge about the process in an easy to relate view. So that's one of the most important ones there. I could tell you a lot of things verbally or written down in directions, but usually if you have a picture, it's a little easier to digest, to understand. And that's exactly what we do when we do a process map. We put steps into like blocks in a sequence to kind of give a very easy view of this is step one, this is step two, and then this is what happens when you run into this scenario. So very easy to look at. Clear and concise communication. People don't like to read. I know I don't. A lot of words, I'm like, no, just give me a picture. Give me the Cliff Notes version. It's like, boom, boom, boom. What do I need to do? So that really is what we get out of process mapping. And we also want to ensure that all aspects of stakeholder inputs and outputs are captured. So that is one of the very important pieces of this. We want different aspects. So when we do process mapping, it's not like we sit down with one person. It's usually a group of people, or it could be like if I did a project for all the sites, I sat down with all the sites together and we went over their process. Because one site might do it different than the other, which they did. And we want to make sure we capture all of it to figure out which one is the best method. When to use it. It says define phase of DMAIC. So we'll talk about DMAIC tomorrow. It's part of Six Sigma. But really, honestly, process mapping is usually the first thing I do for every single one of my projects. It's, we get everybody in a room and we figure out what the process is. And I'll go more into detail on that. But it's usually, of all my projects, I always use this tool. It is always the first tool I use. I use it in 100% of my projects for sure. Suppliers, you also use it when suppliers are not clearly identified. So, we kind of know what the process is, but we don't know who's actually involved in it or putting, supplying stuff to us. And supplies could be information, decisions, materials, all kinds of things, not just materials. We also want to use it when specifications are placed on our inputs and to understand who our true customers are and what their requirements are. So we look at not just the steps, but the people that are involved in the process. So why do we want to do it? First thing, it's easy to visualize. So like I said, it's a lot better than reading a million words. It's easy pictures, boom, 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 and you understand a lot more than having to read. But it's good for everybody. We all get that same communication. There's a lot of them. I'm not going to go through through all the reasons why. But we talked about value added and non-value added. The three things that make something value added. So if the customer is willing to pay for it, if it's done right the first time, or if it changes the product or service. So when we do process mapping, that's usually one of the first things that you'll see. You'll see non-value added tasks that we do. You'll also end up seeing a lot of this. It's like I give it to him, he gives it to her, she gives it back to him, it ends up back to me. I end up, and it's just like a back and forth of why are we, why is this not just like a one time event? Why does it go back and forth so much? So that's usually one of the obvious things that we see when we actually start process mapping. Yeah, that's one of the main ones there. So our approach, collaboration is key. So as I mentioned, we want to get different people in because different people see the process from different viewpoints. And we really need to get all of them in there. If I wrote the process according to you, it's going to look way different if I did the process according to him. So we need to have all the viewpoints in there. So collaboration is key. It's not just one person. And also, it's a good way to get buy-in from the stakeholders. So generally, when we're doing process maps like this, if you're doing one out on the shop floor, the associates get involved. They actually, start verbalizing, well, that's not how the way the process actually works. Yes, it's supposed to be this way, but this is how it actually is. And you start getting buy-in from them. All right, so how to create process maps. So when creating process maps, we work with a group, like I said, multiple viewpoints, and we brainstorm action items. So write down on self-sticky notes or on a flip chart. So that is my preferred method. So I really like to use sticky notes. So some people start writing and they'll do the white erase board and they'll start writing and they'll make their little boxes and all that kind of stuff. I like sticky notes because more than likely what happens is somebody will tell me their process and we get halfway through it and they go, wait a minute, I forgot this one step over here at the beginning. And I mean, it happens every time, because, you get so used to doing your process every day that you forget that there's little steps in there that actually, are important. And there's also decision points, and I'll talk about that here in a little bit, about, what happens when things go wrong. A lot of the times we just say, well, this is my process, but then we forget about, oh, well, sometimes I have to stop and do it differently because of this item that went wrong or something that's just different from the regular process. So we also want to include that. So that's why I really like the sticky note version, so I can move them around as we go through it. And then we also want to arrange the steps in sequence. So that's very important. Make sure you have a direction of flow. So usually it's top to bottom and left to right. If you do that, make sure you're consistent with it so we're not just going all over the place. We also want to interview people in the process to determine whether there are missing steps or decision points. This always happens to me. I'll sit in a room, I'll do the process map, and when I do it on my sticky notes, And then when I go back to my desk, and we have a software called Visio that we usually use. So when I get into Visio and I start putting the process into Visio, there's always spots where I end up like, well, what if this doesn't happen? And you end up with a lot of little missing pieces to your process. It's happened 100% of the time to me. There's never been a time where we get the whole process done right the first time. So there's always a going back and double checking. And if you get different people involved, that's actually even better, because then they could say, well, yeah, that's usually how it is, but there's this one step that you're missing. So that always happens. And then the last thing is walk the process to confirm your understanding. So remember I said there's a lot of Japanese words in this? So that's what this is, genshi genbutsu. So it just means go and see for yourself. So basically, I could have all the people from receiving in this room have all their viewpoints, and they're all telling me exactly what their process is. But unless I actually go see, then I can actually get a good understanding, because they could go, oh, well, I scanned this, this, and that. And in my head, I'm thinking the scanner looks like this, but in reality, it looks different. Or they could say in my workstation, and I could have a pre-assumed, this is what their workstation looks like, but in reality, it could look completely different. So absolutely go and see. Highly recommend. So there's different process map levels, and that's really what I want you to take out of this diagram here. So it all depends on your project. So if your project is, we don't have to get into all the weeds of who does what and all that kind of stuff. A macro level could be a good process map for your process. But a lot of the times that's not the case. A lot of the time it's you have your big steps, but then you know that one of them is causing an issue, and that's where you start going into a micro view of it. So that's where you actually say, like if this was Ingram, you would have receiving, put away, shipping, well, shipping would be 5, quality, pack out, quality, and then shipping, right? And if you have a problem with put away, then that's where you actually start going into put away and seeing all the who does what, who brings in, who takes out, and all that kind of stuff. Okay, so this one is really a good reference sheet. This is some basic process mapping symbols that you will see. So when we start or stop a process, you usually have an oval. And I say usually, some people don't start it with an oval. I never started with an oval just because, I don't know, I'm used to always doing a task at the beginning. I should probably, but I don't. My bad. So then we go to the process task, and those are usually, a rectangle of some sort. So that's why I like the sticky notes too, because you can, they're nice and symmetrical and all that kind of stuff. So you can make those your process tasks. And then you have decision points. So decision points are diamonds. And usually out of a diamond, you have 2 outputs because it's a decision. It's usually yes or no, or you take this route or you take another route. Decisions are diamonds, and that's the other reason I like the sticky notes, because you can just turn them sideways and they turn into a diamond. Time is triangles, arrows is flow, and inputs and outputs are the parallelogram. So I wanted to show you. So we do have that here at Ingram. So this is one of your procedures. This is actually non-conforming material process control. This is QSP 1.24. So here in this procedure, you have all these words, right? Word, 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 word. But at the end, we do have these process maps that basically is just a summary of what all those words are. So here they start with the block, just like I usually do, not with an oval. And they say, this is the beginning of your process. And so they are going top to bottom, left to right. They have that constant flow. So here, first step is identify product as non-conforming. All right, so we identified it, not conforming. So the first question you should ask yourself is the product labeled correctly? So here's your decision point. You have 2 outcomes. It's either a yes or no question. So If the answer is no, it's not labeled correctly, then you go down this path. You notify this person, then this happens, then that happens, and then here is the end of your process. The end of your process is stock product or prepared product for shipment. If you went the yes route, that it is labeled correctly, the next question is it sellable or not? If the answer is no, you go down this path. If the answer is yes, you go down this path. And then here it even comes back sometimes and goes around the other way. So that's an example of how we have process maps in our procedures. And this is way easier than all these words right here. Very visual, and you know exactly who does what and what are all your decision points. Okay. So process maps. So this is really important. I've added this slide. It actually wasn't in our last yellow belt, but after I was reviewing it, I was like, this really, really needs to be in there because it is very important. So when you do a process map, you can actually map 4 different perspectives. It's what you think it is, what it really is, what it could be, and what it should be. And it all depends on the viewpoints. So if I wanted to take a process map and just like this one here, you know, I already have it written up. It's already ready for me. This process map is what the process should be. This is what the SOP says it should be. But when I go out to your floor, is it what's really happening? Maybe it is, maybe it isn't. So that's why it's important. It's not just, oh, well, this is what it should be. Yeah, that's what it should be, but let's actually see what actually is happening. And more than likely, if you're having a problem where you're going to start a project and you have to do a process map, more than likely, then you're not following your procedure, or your procedure is not working very well, or it needs to be revamped for sure. So in the beginning of a project, when you're trying to define current situation, it is as it is. So that's at the beginning of the process, beginning of the project, when you start process mapping. And then from that, usually you have your brainstorming and you develop a future state map at the end of what the process is going to be like in order to eliminate the problem that you were trying to fix in the beginning. That's the whole reason that you had a project in place. Okay, so there's different kinds of process maps. So I talked about, you might have a macro level and micro level where you get into all the details. One of my favorite ones is a swim lane. The reason I like a swim lane is, you saw the process map with all the things, and in the box it says who does what. But when you do an actual swim lane, you actually break it up to visually, you can see who does what. So it's made up of 4 parts. You have your players, so the person, organization, function that is doing the task. Then you have the activities, which are the tasks. Then you have the sequence, and it's all relative to time. So you have it left to right is the sequence of time. So there's the beginning and there's the end. All right, so we're going to go ahead and do a little swim lane to kind of break up the, to get y'all a little active. Did y'all have lunch? You're all like, it's nappy time, huh?
Busy day,
Busy day, busy day. All right. So what we're going to do is we're going to go through a swim lane for inbound. So any of you are inbound? Dang it. Because I don't know outbound that well.
I'm not outbound neither.
We have a kind of idea in the inbound. So.
Okay. I kind of have an idea of inbound. I was going to say it's the best one, but whatever. All right. So we'll go through inbound. And let's say that the reason we're doing this process map is because we found a problem. And the problem is for inbound, it is we get product and the quantities are wrong. Okay. So that's our scenario. So our scenario is, hey, we keep getting, this inbound process where no, let's go PO. PO is wrong. There's PO issues. Y'all have a PO person here? How's that work here?
I don't think we have a dedicated associate. So we have an associate that, recon the POs or work in as we bring in the loads.
Yes, right. So we have that in Fort Worth as well. So I didn't know if that was like standard. Like we have a guy and we did a process map and we called him P cubed, PO problem person. So, so yeah, we have a P cube guy. So y'all have that here?
So we don't have I don't think we have a dedicated associate just for, the POs, but we have a scheduler / then we have a coordinator that kind of work with each other.
Okay,
Yeah.
all right. So let's go. All right, so you kind of have a gist of the inbound process. All right, so we'll start first with the truck gets here, of course. And the first person that touches the truck is who?
The unloader.
Okay,
The first person should be the one that is, checking in with the truck, right? So checking in at the security, as they're docking, or, when they're checking in with the appointment, hey, I got an appointment.
who is that?
That would be, I'm just gonna make it up, I mean, I know the gist of it, I mean, I would say the person coordinator.
The coordinator. All right. So we have the coordinator and they talk to the driver, right?
Yep, the driver says, hey, I'm with this company, I have this PO.
Talk to driver and they tell him which dock to go to?
Yep.
Tell which dock.
Come back, too early or too late.
So we have the driver. Yep, these sticky notes that I got flip flop. I keep right on the wrong side. All right, so then we got the driver. So the coordinator talks to the driver, says go to the dock. So then the driver drives over to the dock. So then the unloader starts unloading the truck, right? So they unload it, then what happens?
Verification of the packing slips,
Who does that?
the unloader,
Okay. So they verify the what?
the packing slips for the
Packing
pallet,
slips.
for orders that come in.
So he's driving the load
The
off and
unload,
doing it?
yeah, the unload, and then they'll verify it, in the
Oh,
pallet, and then they have to give those, they turn those in. So if there's any discrepancies on there, they write it on.
the actual
on the
unloader does
unload.
that.
Yeah, they write the discrepancies on, and they turn that in, and then they go connect with the driver.
Okay.
Through the coordinator process. Because it's the way it is, it's because of streamlining, so you're doing the unloader with the verification of the processes before it gets to the processor on the floor.
Okay.
And then the processor will do the door logging. And
Who does the door logging?
after the unload, when they do the verification, and then they get that, they door log.
The unloader door logs
No,
it too?
the
Oh, okay.
processor. Yeah,
I'm gonna put door logger.
yeah.
So they door log. Okay. So where would where?
Now, you need to keep in mind, this is far as we know, who knows what changes they made in since. So
That's
this is
why
only
we-
on- this
That's
is
why
only
we
on our-
gotta go.
Yeah, this is only on our information, so when they do their process streamlining, it'll be the actuality.
Because I don't think the unloader is actually QA. I've witnessed they have somebody else QA the pallets.
The door logger. Well, I don't think it's QA, right? They're not
They're
technically
just
QA.
verifying the information.
That's
the
a door
paperwork,
logger, right?
and the
Yeah, that way they
pallet.
can reject it at that point instead of having it, you don't want it going all the way on the floor and then.
Yeah.
Right.
It's like a simultaneous drawdown.
The reason I'm asking so many questions is because in Fort Worth, we had a shortage of drivers. So like the drivers were just strictly just unloading, and they were like, somebody else does the paperwork because the drivers were so scarce that we couldn't spend time having them do the paperwork. They shifted that operation to somebody else. That's why I was like, what?
So I'm pretty sure we have the same thing.
Okay.
Because I've seen and receiving multiple ways, with the mobility when I was there. So we have an unloader that's unloading, and we have a processor that's confirming the pallets, so.
The balance of the counts to what's on the packing list.
Okay. So,
Labeling.
Put it this way, we've been chopped this whole process, not knowing what they're doing with it.
right? That's why it's important to get the people that actually work it to be a part of a process mapping. See, I'm making points left and right. Okay, so where would we find that the what did we go after? We're going PO problem. Where would we find that there's an issue with the PO?
At the QA. When they're checking quantities.
The unloader or the door logger?
I don't think the door logger is doing that, but say the door logger, I think it's somebody completely different.
I think it's gonna be, have to be a processor when they're processing the pallets.
After door logged or before?
After door logger. Door logger is a processor?
Yeah, so it has to be before door logger, because door logger is gonna put in, if it's correct, because if the unloader is checking it right there, that's gonna be stopped, that process. Because you're not gonna wanna keep door logging that total if the whole thing is like it's half and half. If they brought the wrong pallet with the wrong, because you could have mixed POs in there when the driver.
Let's go with that scenario.
So if it's like mixed POs,
Yes.
they gotta verify that before they can door log anything, because at the door logging, they might not be able to door log the whole thing. They might have to door log a certain portion after they get the verification.
So that would be the unloader. They unload the truck, they verify the paperwork to the pallet,
To the back.
and that's who finds a
Yeah, they'll be the first line of defense on that one.
PO problem. So what do they do when they have a PO problem? They don't just let the door logger have it, right? There's a stoppage there. So there's a decision point.
Whether you're gonna reject the load or not.
Yeah. Who does that?
That would be, driver getting with the coordinator, hey, we have an issue, we have a PO issue.
Okay. So get with coordinator. Goes here. So if they have a PO problem, so the answer is yes, there's a PO problem. So yes goes this way. No, there's no PO problem. It goes to door logging. Actually, there's probably like 30 other problems that we could end up here, and it's gonna go. But for this example, we're just gonna go this one here. Okay, so then they get with the coordinator, then what happens?
Coordinator, look into the issue, look into the, what do we use that for receiving, info? The system?
But I don't know if they still do the A stage, to report it.
So they look at the system, that what they should be getting and what the, issues are with the shipment, verify it, make the decision, either we receive it or we reject it.
So there's another decision point. Do we receive or reject?
Accept or reject.
So if we reject, what happens?
Get those back up on the truck and bye-bye.
Okay, so if we reject, the unloader loads it back on the truck.
Yep.
And then the driver takes it back.
Probably very confused too.
So I run out of space. We're gonna go here to unload, and then from there we go here to take back your truck. But if we do receive it, what happens?
If we do receive it,
Door
then
log.
So is there a receiver? Oh, it goes back to door log.
If you're receiving
So receive goes back to door logging here. And then after door log, there's a receive step, right?
Doesn't go to the, follow the people there who are resolving issues on the board?
No, I mean, this is all good to go, right?
Okay.
So this is.
Yeah, we
when you
received
receive
it and it's good
So
and
it
we're
goes
door logging.
acceptance, door log, and then a door log, you have the sortation depending on who's door logging, whether it's LTL or small parcel.
Okay.
Yeah.
Oh.
So you have the sortation there. But you're gonna door log everything in, but you don't know if you have to put in the tote, or if it's a full pallet, because then this thing, I don't know if that person's receiving a full pallet or small parcel.
Okay. So
And
door
then-
log, and
yeah.
then, so you have LTL or small parcel. So there's a decision here too, of which way. So if it's LTL, it goes through one step, if it's small parcel, it goes through other steps. Okay. All right. So we're gonna stop there. Cause we could go on for a long time. But what if it was the perfect process? The perfect process would be that happens, they unload, they verify, they door log, and that's it. So all this other stuff here, this is all stuff that happens because your process isn't perfect. Because there is, and we went through one thing, a PO problem. And it, look at all these extra steps that were taken just because of a PO problem. And I know that's not the only one. You also get the wrong quantities, the wrong stuff. I mean, there's all kinds of things. So there's all kinds of other issues. But that one right there, adding all these extra steps. And you can see the back and forth, it's like here and it goes there and it comes back. And here, the driver should just drop it off and go home. But no, he's having to take stuff back. And the unloader, he unloads it and has to load it right back. So that's really what we want to get out of it. And if we sat in a room and just wrote everything down, can you imagine? But that's why a swim lane is good. You have your people, you understand the flow, you see all the back and forth, and you quickly identify what the waste is. We already know this whole thing is a waste in your process. So that's just an example of how we do swim lanes. I hope y'all can see it out there, hopefully. So-
Waste, but it's a necessity, right?
Sorry?
It's a waste, but it's a necessity that we have to follow that process. Otherwise, what's gonna happen with the freight?
So it's not necessarily a necessity, but it is a waste. The idea being, even if it is a waste, we could improve it to the point where it is the most minimal waste possible living in our current process. We could push back on vendors that as soon as there's a PO issue, that it is instantly rejected and they need to solve it on their own. But chances are, you also do business type scenarios.
Yeah. But I mean, these are opportunities. I mean, what if we actually did a project on getting to the root cause of why we have the PO problems to begin with? And I guarantee you it has zero to do with the ALC. That PO problem was triggered off before it even came in through the door. There might have been a mistype in the information at the vendor level. It might have been the vendor themselves. There's a lot of different things. But it's something that you guys have to deal with.
Right, it can be a business case, just how many times that vendor had a few issues and track that up and go back to that.
My first question would be, is the communication there? So does the vendor that buys this stuff, do they know that you've had 50 PO problems this month? Or are they just sitting in la la land thinking, oh, everything's great, The ALCs are just humming along. There has to be that feedback loop as well of, hey, and we get into that with voice of the customer and that sort of thing, where you're closing the loop and you're like, hey, this is causing us issue. And, it could be that they just don't know. I mean, do we know if they're getting the info? I don't. So. All right, so swim lane, any questions there? Pretty easy, right? I mean, self-explanatory, but very important. Get a lot of different people in the room. People actually work the process, or else we're guessing. And, follow the scenarios. So, I actually did both scenarios off of that one and both scenarios off of that one. Good. I always forget one. I always go back and I'm like, wait a minute, there's something missing. We good? You want me to go do a process map of your area?
For maintenance, that would be
Yeah.
great.
I can. You'd be having all kinds of things.
Be good though.
It would be. And see how simple it would be? Like for you, for maintenance, this would actually be really good for your process because you do so much troubleshooting, right? And usually you have a set troubleshooting of we do this, if this, then this, if that, then this. You would have so many diamonds in yours because you do so much troubleshooting. So, absolutely, we can. All right, so we're gonna get into value stream mapping. Oh my God, I am right on time, you guys, to the minute. Man, so pumped. All right, value stream mapping. Has anybody heard of value stream mapping before? Yeah, no, okay, cool. So this is just an intro to it. So as I mentioned, value stream mapping events are pretty extensive. So it's not something you do at every project. So I'll start there. So process mapping I did do at every single project, just so we understand and just so I understand really, because it's like when they give me a problem, they're like, the problem is PO problems, and I'm like, okay, well, what's the process? Who's involved? And right there, I mean, there's 4 people involved in that little tiny section. So for me, it's like, okay, I know who to talk to. I know what kind of steps they have. I'm probably missing others, but that's okay. It's a good start. And it gives me a good baseline, I guess you could say. Then I would go out to the floor and actually look at it and say, oh, okay, yeah, it actually does look like this, or it doesn't. So process mapping, every single project I do one. Value stream mapping is a one-off. So value stream mapping, there's a big difference between the two. So process mapping, we look at every step. So kind of like we did here, step 1, 2, 3. We break it into activities and sub-activities. So the activity is receiving, the sub-activities are all these steps. We define the flow. We're going from left to right. And we focus on correcting flow and identifying bottlenecks. So I didn't see any bottlenecks just yet because I didn't put actual times on here. So usually when you put times, you could say, oh, this takes 5 seconds, this takes 30 minutes, this takes 5 seconds, You start looking at that, you can see bottlenecks. Here, we weren't really focused on that. We were just looking at the flow itself. And then we could see how we'd correct the flow. So I would correct this section here. So that's process mapping. Value stream map's different. Value stream map is very high level. So remember, it was like task 1, 2, 3, 4, 5, and it wasn't into the micro level. That's what value stream map is. So we identify activities, not every step. That's on your quiz, by the way. If you want to take note. And we track one path, and it is just one path. I have seen value stream maps where you map 2 paths because it was 2 big operations that broke off into it. And the activities are listed as wholes, so we don't get into all these levels. It would just be receiving. We define the flow, and we focus on value versus non-value.
How many questions is the test? 10?
No.
Don't tell me 95 like I saw it on YouTube.
95? Who said that?
Well, I checked the course for Six Sigma on YouTube. It's 12 hours with 95 questions.
For yellow?
Yeah,
12 hours.
12 hours with 95.
So I need to double my learning then. That's what I just heard.
Please don't. Let us finish after we finish.
That's what I heard. Did y'all hear that? I heard that. I heard he wants twice as much class.
No, I didn't say I won't.
No worries. It's 21 questions. No, you get it tomorrow. It's very easy. It's open book. All right, so approach to value stream mapping. So there are tenets to value stream mapping. So number 1, understand value. Does that sound familiar? Yeah, we talked about it yesterday. So remember, understanding value from the customer's perspective. Absolutely true there. So we want to understand value. We want to focus on the outcome. So we want to walk the process. We work backwards. We start with the customer and what they value. And we define value stream map, we quantify and capture wait times, and we identify process data. So here in this one, remember, I didn't capture any times. In value stream mapping, we actually do. So this is not value stream mapping. So value stream mapping looks like this. So this is a swim lane. It looks like little swim lanes, like what Olympic people swim in. But this is what a value stream actually looks like. So value stream mapping has its own symbols and that sort of thing. So this is usually when we start a project and look at the value stream, it usually looks like this. And then towards the end, we change it to a pull system and it looks a little more like this, the future state. So I'm gonna pop a video open that'll give you a little bit better insight into it. I hope the audio works on this one. It probably won't. Dang it. It doesn't. All right, my online people, you're not gonna be able to hear it, but you can watch it on your own. I think it's y'all's TV. There's something about the TV itself that I can't share the audio.
Yeah, we need a bigger one.
Oh, you need a bigger one.
More sophisticated.
You know what?
Yeah.
I'm all about it. You don't have to convince me.
When was the last time you went to buy a car and found exactly what you wanted? Because of the vast number of options, most customers end up compromising, like buying a color they don't want or paying for a premium radio they don't need. Why do modern-day factories manufacture an abundance of product that sits as inventory, yet they still don't have exactly what the customer wants? Not having just what the customer wants isn't a new problem. While Henry Ford may have been the first lean manufacturer, he produced vehicles for the masses. The rule of business back then dictated high volume at low cost. As Ford shipped vehicles out to dealers, he also kept the plant pumping out more. Ford assumed that economies of scale would make bigger factories even more cost-effective. This meant buying the biggest presses available to stamp out huge volumes of parts. Mass production lowered individual piece prices, and this was great when there was unlimited demand, but not so good as the demand dipped. The problem with mass production thinking is that people are focused on optimizing pieces of the system instead of looking at the whole value stream. A value stream map follows the flow of raw material, inventory, and information within a factory, or all the way to the final customer. Value stream mapping, a tool developed by Toyota, is now being adopted throughout the world. Mike Rother and John Shook, two lean enterprise experts, made the mapping technique widely available through their teaching and books. This tool allows you to diagram your current value stream, identify the bottlenecks that prevent you from making what your customers want when they want it, and then it helps you develop a vision of what your future lean system should look like.
Greatest video ever, huh? So good. Right.
Grammarly does more than catch error.
No, thank you. All right, so yeah, so the book y'all saw, here it is. So it's learning to see, yeah. So it's one of the things that almost every green and black belt is taught. So an event, you know, it has a lot of steps to it, how to do a current state, all that kind of good stuff that he talked about in the video. So let me. I did it in the chat. All right. So, yeah. So, value stream mapping is not something you do at every project. It's basically something you should probably do once a year, once a quarter, depending on how fast your company is changing. And it's a big deal. The way I would usually do it is we would probably spend a few hours training on it, like what we're expecting to see, what it's going to look like, what the process is. Then you actually go out to the floor and look at it, and then you come back and actually map it out. But, like I mentioned, it's very high level. So it's not into the details, it's the macro level. So this is an example of what it would look like here at Ingram. So you have your receive, your put away, your pick, your QC check, your pallet build, and your load and ship. So those are our basic, high level processes, right? And so what we're looking for here is our cycle time and our opportunity time. So the way you read this is receiving, and let's say this is minutes. So receiving takes 5 minutes to process an order. And then put away takes 4 minutes to process one order. Picking takes 3, QC takes 5, pallet build takes 8, load and ship takes 5. Ooh, that's a lot of hours. So it's minutes. So we said minutes, right?
Yeah.
Okay, minutes. So if you had a seamless process where it was one by one by one, you would basically, from the time you receive it to the time you ship it out, would be a total of 30 minutes. That's it. I mean, fast, going through all these steps, and that's their cycle time that you have to have in each step. We talked about standards yesterday. So again, this would be a standard. The standard picking time would be 3 minutes. So that's how we get to that 30-minute cycle time. So that's how long it would take from a product from the time we receive it to ship it out to the customer, 30 minutes if there was a seamless process. These top lines here is like the inventory that's waiting. So receiving put out, and they have 50 minutes worth of work at put away because of what receiving pushed out. So that's how you read it. So 50 minutes for put away, and put away is kicking butt and taking names. They pushed out 200 minutes worth of work over to picking. And then picking pushed out 40 minutes over to QC check. So you can't get one item from receiving to shipping in 30 minutes because of all this inventory that's waiting there to be processed. And so that's the opportunity time. So in reality, for one product to get through this whole cycle, it's 725 minutes, which is the addition of both of those. So that's where we look at the big picture, and that's where we should probably hone in into, well, what's going on between put away and picking that they have so much inventory sitting there? So, I mean, picking a QC check is just boom, 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 but we have a 200 sitting there. And even more, we have right before load and ship, we have 300 minutes worth of work sitting there. So that's where we start looking into what's going on, and that takes us to the next level, where we actually go and look at it. So one of the good things about it is it tells us where not to spend too much time on, right? So we probably aren't going to spend time here in the 50 and here in the 40, but we're going to go tackle 300 and 200. So that's where you start getting into the details there. It's like, what's going on in picking that, is taking so long? So is it people? Is it equipment? All these different things that you would go after and look at. So that's just a big generic view of how a value stream event happens. So, how you actually do it, we first would determine the scope of the value stream. So first and last steps. So here we had 6 steps, but maybe we only need to look at 4, or maybe we need to expand it to 7, depends on the problem that you're having. And depending, on, because I think what is it, LTL probably doesn't have half of these steps either, right? It's just
the pick and the pallet build, and then you have the load and ship. So
yeah.
3 of the.
Right.
So at least they have 3. But every process will probably have something, because if you have put away, you have your receiving process, and that's it. They'll probably have a connection either way.
Yeah.
Because if they didn't receive it properly, they didn't process it properly, I can't pick it properly, therefore I can't ship it. Because I can't pallet build it, and I can't build it out.
Mm-hmm. You
So
end
it's
up
not
with all
correct
the
from the beginning of
issues.
receiving, I won't be able to ship it out.
It trickles all the way out. I know, I know. Yeah, so that's the first thing. We focus on the scope. What is the scope that we're looking at for this project? We look at the in-between steps. We determine the cycle time for each step. So that'll be where your standards come into play. If you don't have a standard for the area, maybe we go off and do time studies or pull some data to see, trends and that sort of thing. We also determine waiting time for all the inventory steps. So it's a snapshot. So we would go to like pack out and say, how many orders do they have sitting there right now? Or you could look at it as an average, over the last 10 days that this many was the average of the orders that were sitting there. You identify movement to the customers, suppliers. We want to document customer and supplier information and identify information flow. So that's the other important part. So here we didn't talk about the flow of information, but in value stream maps you do. And there are these little icons up here, the little lightning bolt looking one, that's a flow of information. So it's not a physical item, but it's the information. So this would be like the orders, the forecast coming from the vendors on what we're looking at. That would be a flow of information. So it's not a physical thing, but it is information. So we note that also on the value stream map. So one of the important things that ties into value stream map is takt time. So takt time is a German word that means heartbeat. Well, actually means beat or pulse is what it translates. So basically it's the beat of the drum. So what is the rate that we should be producing at? So remember we were talking about the customer. The customer should be the one that sets our pace, because we don't want to make 2,000 if the customer is only looking for 35. So that's where we get into the takt time. What is the customer demand? So right here, per shift. So this is just an example. Let's say that per shift we want to get 35 units out. Probably not, that looks like something like we're making big stuff, but you'll get more than that here. So 35 is our demand that the customer is expecting, and it takes us 350 minutes to make 1 unit. So what is our takt time? So that means in order to get 35 out per shift, we need to make 1 unit every 10 minutes because of how long it takes for us. So if you think about cars, that's kind of how it works. They have a demand that they need to push out, and they say, okay, well, we have to get a car out every 10 minutes. And what does that look like? You can't get a car done in 10 minutes, but I mean, you have so many stations, so many people, so many resources that every 10 minutes a car's coming out. So basically same thing here. So we look for the takt time. And so once you find, you do the value stream map, the other thing that we do is called level loading. So more than likely your process is going to look like this, which it kind of did. You have one area that has 50 minutes and one that has 300 minutes worth of work. And what we try to do is we try to level load it. So how can we get it more to where it's level? So we have different techniques. You can move work from one station to the other. You could add more stations, you could add more people, you could add more equipment, whatever the case may be, to where it's more consistent and you're meeting your takt time. Level loading. So everything I just said. We level the activities across the processes in order to make our takt time. All right. So that's just an intro to value stream mapping. There's a lot to it. It would take us all day to teach value stream mapping. So we talked about process mapping and value stream mapping. What is the key difference between the two?
Value stream mapping, high level.
Yes, absolutely. And the process mapping?
The micro level.
You start getting into all the different steps. Absolutely. So can you perform process mapping and value stream alone? Why not?
I mean, you can do it alone. You can do it alone, but it'll help to depending on what you're looking at, right? So process mapping, you need inputs from all the whoever is involved in the process, right? High level value stream, I mean, you can do it alone, I think.
Yes. Yeah. You don't have to use both. Process mapping. Can you perform process mapping or value stream mapping alone? Oh, I misread that. Okay. I thought you have to use one or the other together, and the answer is no. But if it's saying, do you use it alone, like I'm going to process map the whole place by myself? No, that's a no. You have to have people from all the areas, of course, yeah. But you don't have to do process mapping to do value stream mapping. It depends on your project. You said depends, and absolutely, it's what we're after. If it's, we want to get a state of how the company's running right now to see if there's projects that need to be done in receiving or whatever, because they're the ones that are the bottleneck to the process and that sort of thing. Yeah.
But does value stream need the process mapping?
No, because you're going high level. We're just
So if I
looking
do
at
totality,
receiving.
I don't need to know the sub-functions of it, that's all I.
No, unless you realize that there's a problem. So you would look at it like this. So you would say, how much is receiving? How long does receiving take? On average, it takes 5 minutes. Okay. How many things are sitting there waiting to get received? 1,000. Okay, so 1,000 times 5 minutes. This is how many hours of work there's waiting on them. So I don't have to know all the things that happen in receiving. I don't have to know the door log or all that if I know the average time it takes to receive a standard. Because here we're looking big picture of what area is not letting your process flow. And it would probably be what's happening right here between pallet build and load and ship that you got so much sitting there waiting on it. Everybody else is working and punching it out, and then it just sits there because why? And then that's where you start going into maybe we need to process map that area to see where's all the waste in it. Does that make sense?
Oh, okay, so it's backwards. Like if I find the totality, I'm going to the totality first, and then I'm going back to
Yeah.
figure out the totality.
Right. We look at high level to see which one is we need to focus on.
Okay. So
And
the
then
problem,
once you focus, you start to.
have to go back, yeah. So
Right.
you have to-
So generally we do value stream map once a year, once a quarter. We do it once, and then you'll say, oh, there's a problem going on over here in load and ship because we're not getting, stuff is sitting there. It goes to the 8 ways, you over processed and it's just sitting there. And it's like, how do we get it to where we're meeting the customer demand? And we did say we go backwards too. It might be that they're pushing it at you. You don't actually even need it. Kind of like the boxes. The boxes that they're making, they're just pushing them out. Do you even need that many boxes today? Or are they just working because they're working? That sort of thing. All right, we're at the hour mark. You want to stand up and stretch a little?
Sure.
Stand up and stretch. Did y'all ever watch 30 Rock? There was a thing where they had a 1 minute dance break. They're like, boo, 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 boo. Yeah. And I am right on time, you guys.
Are we done?
No, we're not done. So it said stand up and stretch.
No,
Y'all been sitting there.
what I didn't get,
Sure.
I don't know about Ingram, but like my previous job, we don't focus inbound. Okay, let's find a solution, make a map outbound. The conflict happens between inbound, outbound maintenance. They have to communicate. They have to find a solution, put a map together for conflicts with operations. It doesn't happen here.
A map?
Yeah.
So is it like
Like
total
why we
productive
have
maintenance?
slow, for example, like why we are slow on loading, why the buzzers are going, what's the solution? We have to create a map, try to figure out why everybody goes on lunch at the same time. Like there are a lot of stuff, they have to be like communication between departments, but based on Six Sigmas, each department is separate from the others. Unless later on they are gonna surprise me and.
No, it's not. And that's kind of what we're getting at. That's why we do the value stream map. so we could see Ingram as a whole, because this is Ingram as a whole. This is not just receiving, so I'm not just going to receiving and doing a project
No, I'm
on
not
them.
saying you, but I'm saying like, okay, why there is a delay there? Now we know why there is a delay there. But like maybe inbound, they don't see the root cause of that delay. But because maintenance is involved in it and everybody is on the conveyors trying to move boxes, they know like,
You see everything.
we see because we are on the floor all the
All,
time.
and you see the whole value stream map. Yes. No, and that's exactly it. I haven't seen a single value stream map here at Ingram at all. So nobody has done this that I know of just
No, there
yet.
are no maps.
Right.
I'm used to work on maps on my previous job.
Yeah.
And try to find solution for delays with operations because all departments are involved and they all try to find a solution.
Yeah.
But if inbound is trying to work on their own issues, there is no communication with other departments. And when you are outside the circle and you are called to go and help, you see better than people inside the circle, and they are getting dizzy with all operations, and sometimes they don't see the solution.
Yeah. So what we call that is silos. So everybody works in their own little silo. And that's really why we do the value stream map, exactly because of that case. Because I only see all my problems in receiving, and you only see all your problems in LTL. And there's not that clear cut vision of what the actual everything looks like. But you see it. So I need to come to you to do my value stream mapping. All right, let's go. Let's get back.
I try to stay quiet, but sometimes I
No, this is good. I mean, that's what we're here for. We're here to learn. And I've only been here 8 months, so I got a lot of learning to do for sure. I know these tools. I know how to use them. I know how it works and everything. I just need to know how to apply them here.
We don't have site-specific granular process maps at all, do we? How about non-site-specific process maps?
I've seen very little process maps. Like in the procedure, like the one that I showed you, like there's somebody had an attempt at it. Right. But like for me to walk in the door and be like, what's your receiving process? And somebody goes, here you go, already mapped out. I haven't seen it. Maybe that's something we need.
Yeah, I know.
All right, let's get back into it. So 7 basic quality tools. So some of these you've heard, some of them you haven't. Hopefully you've heard all of them. But basically, we talk about the quality tools because there is a cost of quality, of course. So there's cost of good quality and there's cost of bad quality.
Cost of poor quality?
Huh?
Wouldn't it be cost of poor quality?
No, I'd say bad. It's good and bad. I won't spend too much time into it because I like to get into the actual details, the tools. So why use quality tools? We can't improve what you don't measure. I mean, you don't, and it goes back to the feedback, giving people the numbers, does the vendors know that you got this many PO problems happening? Is there something that can help us do to alleviate that? But basically, if you don't measure it, how do you know if it's good or bad? And I talked about it the first day, if I'm sitting here and just working and I'm getting 30 picks per day and I think I'm doing great, but the standard is 60, it's that feedback to measure stuff. So we also use them to prioritize what is important. So you might end up with the process map where there's like 300 things wrong, but you can't tackle all 300 right away. Which ones are the important ones that you need to go tackle? So we'll talk about that. Control variability levels. I'll get into all the details of this one, but this is the reason why we use them. So there are 7 basic quality tools. So this is not something I made up or Ingram made up or anybody. Is this coming from way back when? So there was a man named Kaori Ishikawa, and I mention his name because it'll come up again. So in the 19th, no, I won't tell you the quiz answers if you want me to. So back in the 1950s, he developed these 7 basic quality tools. So he also developed a concept called quality circles as well, where he focused on quality. So each tool has a different application. So, in this course, we're going to teach you a bunch of tools. You'll get a good, picture of, oh, I know when to use this one. Maybe I should use this one. Like process map, always use that one. Value stream map, we maybe only have to do it once a quarter or once a year, depending on how the company changes. So we'll give you all these different ones. Some of these you'll use on every single project. Some of them you'll just like every once in a while. But either way, they all have an application and it's all dependent on the project that you're trying to solve. So depending on problem or project. And we want to quantify problems, drives, priorities, and thereby solutions. So let's get into them. So there's 7. I don't know why I kept saying 8.
8 ways.
Oh, that's it. I'm like, why was I thinking there was 8? So there's 7. So the first one is stratification flow or run charts. So this is a tool that we use. Basically, we use it for stratification or segregation, whatever you want to call it. But basically, it's formation of layers, classes, and categories. So when you pull data, there's usually a bunch of different variables in your data. And it goes into how do we categorize it. So we categorize into different groups and analyze for trends. So if I pull just a big chunk of data, ways you could stratify it here at Ingram is that you would group it by what. So what would be an entity? So an example would be CLS versus TS. So if you pulled all the damage data out of your damagee form, there's going to be both CLS, TS. So the first thing you might do is say, I'm focusing on TS, throw out the CLS stuff. So that's an example of stratification. The next thing you might look at is who. So resources. This would be like first shift versus second shift. So first shift behaves completely different from second shift, right? So, what is the difference between the two? So if you're looking at your picks per shift, maybe there is a big difference between first shift and second shift, and it's all subjective. You have to know the business, of course. Where? That would be like a place. So if we're looking at data and we have all the 5 ALCs in there, we might need to stratify it to, how much is Texas, how much is California, how much is Jonestown, all the different places that we have. And then when is also important. So think about your data and think about your actual process here in a year. So what does that look like? Your volumes are all over the place, right? You have peak season, they're through the roof, and then, at the beginning of January, they're almost nothing. So that's another reason why you would want to stratify it. You don't want to go try to solve a problem and think that, your volume is going to be constant throughout the year, because it's not. It's, peak season versus non-peak season, or maybe you just want to look at a month. So maybe just the month of August is representative. So maybe just look at it that way. So that's all stratification is just knowing your data and know the different groupings that you should look at it. And we have check sheets. Most people don't use this one, but I actually think it's one of the better tools. It's very, very simple. I mean, so simple. And it's very versatile. You can create a check sheet for whatever your problem is. So an example is when you use check sheets is when you need to collect data, but it's not in your systems. So for example, we kept talking about, your scanners losing connectivity. This would be a great way to figure out how many times that happens. So you would put out a check sheet, because you can't track it through your system. There's none report and IM polls that you can pull out that says you lost 3 hours because your Wi-Fi wasn't there, whatever the case may be. So you have to kind of somehow still gather that data, and this is a very easy way to do that. So how you would lay it up, at the top it has the days of the week. And you could give it to the person to say, okay, these are the issues that we're looking at. We're looking at how many times your Wi-Fi goes out, how many times the scanner stops working, how many times whatever the case may be. And then they would sit there and start checking it, And then you know, at the end of the week, you have, you know, 20 people's sheets, and you could say, oh man, something happened on Monday. Everybody on Monday had this issue. Or you could say, oh, look, you know, it's the Wi-Fi that keeps going out on everybody. And it's consistent throughout the whole week. So, you know, stuff like that where you actually start building a case of, okay, so it's happened 45 times in the last week. And, you know, each one probably took about 2 minutes for it to occur. So 45 times 2 minutes is 90 minutes worth of lost time and that sort of thing. So it's really, really easy. That's what check sheets are. But most people don't use them.
IT department should provide a report with how many minutes signal was lost. I was used to get that.
You did?
Not at Ingram, but IT department is able to say this location, like they had disconnection, for example, in receiving for 60 minutes, 62 minutes. They were used to track it.
Really? Do we have IT here?
We don't track over here. So, you know, we basically have to
Do it manually.
let them know, hey, we are down for
But it's
30
not
minutes.
accurate because sometimes associate reported after 10 minutes, and when they get signal, they tell you after half an hour, oh yeah, I'm back. When you ask them like, do you have signal? Oh yeah, I'm working. You don't know. It's not accurate.
Yeah. No, yeah, that's part of it where, you know, if you're having to do it manually, I mean, you're still kind of going to run into that. But at least, you know, it's better than, you know, right now, if I ask you how many minutes did y'all lose last month for Wi-Fi, not a person in here can give me a number, not even a ballpark. I don't know if it's 5 minutes or 5,000 minutes.
The goal would be for that type of sheet. Right now, it would be data that we couldn't even give a shot in the dark. You do it manually, you're at least getting into the ballpark. Is it completely 100% accurate? No, but is it 80 to 90% accurate? And if it's 80% accurate even, that's still 80% more than what we know now.
Right.
Better than zero.
Better than zero. Right, because, you know, nobody can tell me, you know, if I find out tomorrow the fix is $10,000, nobody can tell me if it's worth it or not. Am I losing $30,000 worth of labor? Or am I losing $2,000 worth of labor? I don't know. Am I going to spend the $10,000? If I go to ask, you know, the higher ups, I need $10,000. They're going to be like, show me the money. I'd be like, show me why I need to give you $10,000. And if I say, well, we collected the data and it's a $30,000 damage, they're going to be like, okay, here, got the CapEx. We'll get that fixed for you. Yeah. All right. So the next tool is histogram. Histogram. First things first, this is not a bar chart. So a lot of people see it and they're like, yeah, I've made a bar chart 100 times. So this is not a bar chart. A histogram is different. The key difference is that the bottom, the x-axis, is a continuous range. So on bar charts, you have, like you could have a bar chart for the different sites and their damage, right? So you would have Miraloma, Carroll Stream, Fort Worth, blah, blah, blah. And each one would have their total amounts. That's what a bar chart is. But a histogram is actually showing the distribution of your information. So for this example here, it was like we're manufacturing something and we want to know, you know, it's very crucial that we know how much it weighs. So somebody sat there and weighed it and said, okay, so the average, the one that happens the most is about 138.5 pounds. But it could go as little as 132 and as heavy as 148. So let's say you're making, I don't know, something that weighs that much. I need a good example for that one. But something that weighs 140 pounds, you know, if you're shipping it out and your system says, you know, 138 is what it's supposed to, and I got 10 extra pounds in there, you know, it's going to throw your weight off. Like my luggage almost got, they almost charged me money because I was 5 pounds over coming over here. I was like, anyways. So this really gives you a distribution. You know, the average is here, most of them are there, but you do have some that are really heavy up to 10 pounds, and you do have a few lighter ones that are down to 132. So it's more of a distribution, but it is a continuous range at the bottom. So not a bar chart. And there is some in Excel that will build a histogram for you in the add-ins. So you can make that in Excel, very simple. The next quality tool is a scatter plot. So scatter plot, really what we want to get out of it is there's a relation between two items. So an example of this is, you know, if something increases, the other thing increases. So more than likely, if your volume goes up, your quality defects are going to go up. So why? Because you generally have more opportunities. So, you know, there's more likelihood for you to mess up somewhere. Another reason is usually if you have a large amount of volume, you know, did you staff correctly? And if you didn't, everybody's taking shortcuts and hurrying through the process. And every time you do that, more than likely, you're going to end up with more defects. So that's what a scatter plot is to really get into, are these two things related? So can I control one by controlling the other? And as you get into like heavier projects and you get into your critical X's and your Y's, then you kind of figure out, oh, these two things are related. So I can do some mediation there. Control charts. So this one I think is really good. I think we could actually use this. So control charts they track the process performance over a period of time. So there is a sequence here. So either it's days or hours or something, and it goes throughout time. So this could be an example could be, let's say the picks per shift that you got out every day for the last week, right? So you had one day where boom, you had so many picks, and it's like, awesome, we did a great job, you know, and then it just started trickling down. So what this does, it really kind of just gives you a visual to go and see, you know, what's actually going on in my process. You know, one of the things that would spike out to me is this point right here, these points that are way low, where you would say, you know, what happened these days that my picks were so low? And it could be, oh, well, that's the day you had that staff meeting and, you know, people were pulled out for an hour. Or, oh, that's the day that the power outage happened and, you know, you couldn't get all your picks done. So that's what a control chart is for.
Look at the first couple, Joe, why are we doing so good? And how can we just keep that?
And it could be that you had everybody staffed correctly, you know, or you had extra people, or it could be that your forecast was way off and you didn't have the volume that you were supposed to. So you had too many people for the volume, and so you got a lot of it done because you overstaffed. So the other part of it is these control charts. Control variables, control limits. So you have the upper and lower control limit. So for example, if you have picks, your picks that you said 60 is your standard, you have to have a level that'll say, you know, what's the lowest? You know, if it's this low, you got to go talk to somebody. So if it's 60, it might be like, are you going to go have a discussion if somebody picks 50 and they're supposed to pick 60?
Yeah, so, you know, if anybody has 50 lines per hour, that's like, okay.
It's okay.
It's not okay.
It's not okay.
It shouldn't be okay in a perfect world, right? So over here, like I said yesterday, we're reevaluating our standards, right? But from my previous experience with my last job, if the picks were 100 per hour, if somebody's doing 88, 90, we are talking. Like, we are getting the feedback right away. Hey, what's going on? What can we do to help you to get to that? You know?
So what is the level where you would say, well, that's just okay? So if I'm at 60, if I do 57, you're just like, eh.
You're right, so it's like categorized as A, B, C, right? So,
Okay.
you know, in my mind, not over here, but if, somebody's at, you know, 50, from 60 to doing 48 or 50, then we're still okay, you know, you know, based on the numbers, you're gonna get, at the end of the review period, you're gonna get, 100%, whatever that is, right? If somebody's always at 60, we're gonna give you A.
So that's where these come into place, exactly what you're saying there. So this is 60 here, 50 is about here. So if you're right there at like 44, we're gonna have a discussion today, you know? It's like, wait a minute, you know, what's going on? What if they're having like 100 and something?
Well, we got something wrong.
So it's not that, oh, everything's great because it's high either. There's something going on if you got 100 as well. So that's exactly why we put the control limits. Is like this stuff, it's like, well, that's part of everyday fluctuation. You know, I might have a bad day. You know, usually I'm at 50 and today I don't feel good, so I got 55 and it's like, it's still okay, you know? But, you know, if I dip down to 20, you know, you're gonna be like, Joanna, what's going on? Well, why did you dip so low? And that's what the control limits are all about that we put in there. And it's just a visual, you know, it was really quick and it's like, boom, you know, you could see where you need to go focus your attention. All right, next one is the Pareto chart. So the Pareto chart is, some of you have heard about it before, the Pareto principle, and it's actually, I'll get more into detail on that one in the next section. But basically what it is it looks at the occurrences, and you know, here it has the categories, but it also has this curve that tells you the percentage. So the way you would read it is this category B, you know, has 120 something, out of the total of all these, it's about 40%. So 40% of the information is based off of this B. So if it was defects and these were sites, site B is actually it's 50, is creating about 50% of all the defects. And then you add B and F together, and B and F together is about 80% of your defects. So these two sites are causing 80% of your defects. And then it keeps going. You add B, F, G together, and it puts you, oh wait, I'm reading the wrong one. This is it. 60%. So that's how it is. It just adds up and up and up. And what we want to get out of it is, you know, we could do projects and go tackle all these sites, but we're going to get more bang for our buck going after these two, since they are the majority. Actually, these three probably. That'll get us to 80, yeah. So these three make 80% of the defects. So these, we could do projects, but we're not gonna get that big of a bang as if we go after these three. I'm all touching you. I'm gonna mix it up. So that's Pareto when we get into it. The seventh quality tool, the last one, is the cause and effect diagram, which is called the fishbone. It's also called the Ishikawa diagram. So remember I said who invented these rules? It was Mr. Ishikawa himself. So he created this, and he put as part of his basic tools. So a fishbone is actually one of the better tools. So usually I use a fishbone in probably about 95% of my projects. It really helps to stratify things. So when you build a fishbone, there's 6 categories that most of your causes will land in. So this is about cause and effect. So when you do the effect, you're writing your problem or your goal. So let's say we said PO problems was my problem here. And then we would go back in each category and see if there were things that actually caused the PO problem. So the causes that create the effect of the PO problem. So is it a person, the way the person did the order, that sort of thing? Is it a machine? There's something involved with the machinery that causes PO problems? The measurement, how do we measure the PO problems? So those 6 categories usually will hold most of the causes. So it's really good. I really like using the fishbone for sure. All right, so those were the 7 quality tools. So have y'all used these before? Yeah? Which ones?
Got the name of it. Control chart,
Yeah?
tornado chart, use it, right? Never used that histogram.
Yeah, most people don't. Because it's usually with your distribution is what you're after. And so most people use the bar chart for sure.
Yeah,
Pretty handy?
Probably the cause and effect without realizing it's cause and effect on your everyday. Because you're not realizing you're actually doing it throughout the day. You're just not charting it like you're literally charting through the day without you actually putting on a chart. So you're thinking when you come in the day, oh, this is my issue I had yesterday. So let me figure out how to avoid it today. So today now you're going through the whole floor process that you weren't able to do yesterday because you just got the problem.
Yeah.
And so
But
the next
imagine
day-
if you did.
On that, yeah, because you're unofficially doing charts and you don't realize you're doing it.
Oh, for
On
sure.
that day. So it's not, you don't have a formal name to it.
Yeah.
So eventually you're going to end up doing all these without you realizing you have a name for each one.
That's why they're the basic
They're all-
quality
Yeah.
tools, because they're very basic tools. I mean, they're, you already do. And, when I started the class, I said, continuous improvement is not rocket science. You do this every day. We problem solve every day because every day is different. We all run into issues one way or another. All right, so let's go into root cause analysis. So the way this material is flowing is, at the beginning we started with, a problem. So somebody says, hey, we got a problem based off of our 8 ways from yesterday, right? So yesterday we taught you the 8 ways. 8 ways, go out, look, and you say, oh, look, this is an issue. First step that you should do, process map it. Process mapping, we get into, oh, look, there's waste here. How much waste is there? And then it's when we start using the basic quality tools to kind of stratify it. Is this happening per shift? We stratify the data. How can we go collect more? Maybe use check sheets. Maybe it's a lot of different problems and they're all different categories. Maybe we should do a fishbone and that sort of thing. So we use our basic quality tools to kind of figure out what the problem actually is we're leaning where the problem is. And then we actually get into the root cause analysis. So let's get into what's actually causing the PO problem, what's actually causing the issue at the root level. So root cause analysis, we have this thing called the tree concept. I really like it. I think it's the cutest little picture ever. It's so cute. But the tree concept, it basically has three parts to it. So at the top, you have your symptoms. So symptoms are the things that we see. So what we usually would see is like, a person not picking their 60 picks per hour. So that's the obvious thing. So if you were sick, that's like the equivalent of you sweating. So people see that, oh, they're sweaty, there's something wrong there. But that's all we know, there's something wrong there. And then you get to the actual problem. So the problem is that I'm sweating because I have a fever. Okay, well, that's a problem. But what is the actual cause? That's where you get down to the root. The reason I have a fever is because I have a virus. So I'm sick, I have a virus, which causes my fever, which causes me to sweat. So that's how we get down to the levels. So you might start with the person is not picking their 60 picks per hour. That's the symptom. What's the problem? You go and you ask them, hey, what's going on? Oh, well, I was waiting for my equipment and that's the problem. But then with the root cause, what is the actual root cause of waiting for my equipment? Is it the equipment was broken down? Or is it the equipment was being used by somebody else? Because those are two different problems, right? If the equipment was broken down, you would probably need to go get maintenance to fix it or have a better maintenance program to have it to make sure that it doesn't break. Waiting on somebody, maybe it's because you're sharing the resources and you don't have enough equipment. So those would basically have two separate solutions. But all you see is this person just ain't picking their 60. And that's why we want to do the root, where you get down to the root cause of what actually is causing it, and that's where you actually pick the right solution. So there's three basic tools. There's a lot of tools that we can use for root cause analysis, but there's three basic ones that we use. There's the 5 whys, the fishbone, which I mentioned, and the Pareto chart. So these are very, very handy when you start getting into root cause analysis. So 5 whys is the first one. 5 whys is not rocket science. It's basically what it is, 5 whys. It's asking why 5 times till you get to the root of the problem. So one of the ones that we have here is, for example, the problem is I ran a red light. Okay, so you ask the person, well, why did you run the red light? Well, they ran it because they were late for work. All right, well, why were you late for work? Well, because I woke up late. Well, why did you wake up late? Because my alarm didn't work. Okay, why didn't the alarm work? Because my battery was dead. Okay, why was your battery dead? Well, I forgot to check it and charge it before I went to bed. So the root cause is that my battery, I should have checked it and plugged it in and made sure I had enough juice to where it would have made the alarm go off, and I would have overslept and been late for work, which caused me to run the red light. This almost happened to me yesterday. Last night I was at 19% and I was like, oh, that's not gonna last till the morning. So it was funny because it happened just last night and I was like, I'm teaching that tomorrow. Like, I better plug it in, which I did. So that's really what it is you start asking the questions to get down to the root cause. Another example here is why the Washington Monument was disintegrating. So if you've ever been to Washington, D.C., the Washington Monument's over there. It's pretty neat. It's really tall, really, really tall. So they found out that it was disintegrating. So they did the 5 whys. Why is the monument disintegrating? Well, we use harsh chemicals on it. Okay, why do we need harsh chemicals? Well, there's a lot of pigeon poop that you got to clean off of it. So, you know, most people would just stop there and be like, well, let's go shoot all the pigeons, right? Get rid of them one way or another. But they kept asking, so why are there so many pigeons? Where there's pigeons because of the spiders. Why are there so many spiders? Because of the gnats. Why are there so many gnats? And it's because they're attracted to the light. So what they did is they actually changed the time that the lights came on, which actually reduced the gnats, that reduced the spider, that reduced the pigeon, that would reduce the need for you to use the harsh chemicals. So those are 2 good little examples. All you gotta do is ask why. And a lot of the times, it might look like this. So it won't be just problem why 5 times. Sometimes it's 2, and then it stems even more, and then even more until you get to different root causes. So that's happened quite a bit. I've actually done projects where it was like this, and I had to basically map it out. So there is not a need, you don't have to ask 5 whys. I mean, you don't, you know, if you get to the root cause, you don't have to keep going just because, oh, I said there's 5. So just know when you actually get down to the root cause. But, you know, the facilitator will ask and they'll respond back. And that's usually where you end up with all the different ones because different people have different viewpoints for sure. But it'll give you a good idea of what the actual problem is and what you actually need to solve. So the next one that we do for problem solving is the fishbone. So it's called the fishbone. It's also called the Ishikawa. It's also called the cause and effect diagram. But it basically is called the fishbone because it kind of does look like a fishbone. But what you got to get out of it is cause and effect. So this is your effect, and these are your causes. So everything that causes that outcome. So there's 6 categories that we generally put everything in, and we call them the 6 M's. So they stand for materials is 1. So that would be any supply that might be required for your process. So it could be physical materials like a box cutter, tape, whatever the case may be. And then the next one is your method. So that's the system of work or your paperwork routines. It could be your process, you know, you have to do step A, B, C, D. But is that the right steps? That kind of gets into it. If your process isn't set up very well, sometimes your process could lead you to make errors of some sort. Then there's man. So that's the person, staff, skills, training, abilities, attributes. So generally when I do a fishbone, generally, the first thing that fills up the most is the man. Like everybody is quick to say, well, it's the dude. Why didn't they get 60 picks per minute? I mean, per shift. Oh, well, they're just lazy. Oh, they just don't want to be at work. Oh, they're just not careful. They just blah, blah, blah. And usually that's the one that always fills up. But me, I always think the other ones are really more of the ones that are actually the big ones, because like I mentioned, you can build a process so good you can get anybody into it to work it. So wow. What was that? There's that. So Mother Nature, it just means environment, but they had to stick with the 6 M's because environment, you throw it off. But basically it's your work environment, the physical conditions. So what does your physical conditions look like? You would know. Your conveyor belts, your meat hooks, right? Your the racking.
Make me start.
He's like, let me tell you. Let me tell you everything I need to fix. Right, it's everything. And one of the projects that we were looking at was damages, right? And so we were talking about in-house damages, and everybody was like, they're just lazy. They're not paying attention. They're just, drive recklessly and just put forks through everything and right? That's always the first one that fills up. But then once we started looking at it, it's like, well, let's actually get out to your work environment. What does that look like? How's your lighting? If I'm driving a forklift and I can't even see where I'm going, that's a problem. If the actual racking is like bent and crooked, because y'all know, there's always that in warehouses. You're always going to have bent racking of some sort. So is the racking crooked, and when you get in there, you automatically clip the side of it. So lighting, the bin size. The pallet's way too big for the size of the bin that it was assigned to. The conveyor, man, that's conveyor.
That's really.
One of a kind.
It's like, what year is what year did they put this in?
At your location, they are old like here, 25 years
No,
old.
my site is brand new. My site's only
Oh,
been
yeah,
there
I'm
2
talking
years.
about here.
I know. I was like, oh my goodness.
Yeah, I was a teenager when they.
I don't doubt it.
They don't make them anymore.
They don't, right? And that's the other part, it's like, so what kind of issues do you have with conveyors? I mean, they get stuck, they have sharp corners, and that's just the conveyors themselves. And then you get people involved with it, stick their hands in it.
Oh, yeah.
Right? Throw stuff into it. Yeah, it's a nightmare. So yeah, and then there's machine conveyor belt. So let's talk about that. What kind of machines do you have? Are your conveyor belts, warped? Are they causing you to do that? Your scanners, your guns, they keep messing up and glitching. So that's the other part. And then measurement itself. Do you even have the information to know what the problem is? That's the other part with like the 60 picks per minute per hour. It's like, do they even know? Are you telling them? How would they even know if that 60 was what they're supposed to be at? So those are the 6 categories that go into the fishbone. So you can use the fishbone and the 5 whys together, and they usually do. We get into, okay, well, it's an old building or the weather or constant failures. And it's like, why is there constant building failures? Well, it's an old building, Why, well, we could get into why it's an old building, but I mean, we kind of end there. Maybe that wasn't a good one for me to start on. But, you get into it where and it ends up maybe being in different categories as well. So that's the other thing, that sometimes it'll be in 2 separate categories. That's a fishbone. So that was really helpful. I highly recommend using a fishbone, especially when there's so many different reasons on why problems happen. It helps you boil stuff down. Actually, that was one of the most important tools in one of my projects that I did. Um, so there was this one defect that everybody thought was happening because of the way we were drilling. But then after we started doing the fishbone and, we kind of segregated that, there was a drilling process, but there was also a transportation process that was causing, it was delaminations in a carbon fiber material. Everybody thought that it was all drilling. So it was all the man, right? Because everybody's quick to go with the man. But actually what we found out, it was the machines that we used to transport it. So actually most of the delaminations were happening from the transportation and not the actual drilling. But once we actually got the data and actually stratified it and said, this is what's percentage is that and what percentage is the other one, that's when actually people were like, oh, they have a pre-assumption of things. So very, very good tool for sure. And the last one we'll get into for root cause is the Pareto principle. So we talked a little bit about it already. So there's a lot of history about this one. So this one is this dude from Italy. His last name was Pareto. I don't remember his first name.
Too many dudes in there.
This dude, this sir from Italy, way back when, was looking at the wealth of the population. And I think he had like an economics background of some sort. But either way, he was looking at Italy's wealth, and he found out that 80% of the wealth belonged to 20% of the population. So 20% of the people actually had all the monies. So
Better than now. Now
right?
1%.
1%. I know. Don't get me started. Separate class.
Vilfredo Pareto.
Huh?
Vilfredo Pareto.
Vilfredo Pareto. Yeah, that dude. So, so he started looking at other things, and he kept finding that 80-20 was like a split that just kept happening naturally. So it wasn't just there. It was just like everywhere in nature that you could see. And so basically the reason we use Pareto principle is for exactly what you have from your project. So let's say in your project, you did the process map, it led you to do a fishbone, and in the fishbone, you ended with 100 different things, right? Well, if we follow the Pareto principle, if we focus on just 20% of those, the critical 20, we're gonna get 80% of the results.
We get rich.
We get rich. No, but I mean, it's focusing, if we don't have enough resources to go tackle all 100, let's figure out which was the vital few, the 20%, and that can eliminate 80% of your problems.
But you have to get a accurate choice. What are the most important things, the 20%? Which one are you gonna pick?
You're gonna pick the 20.
The problems that are happening in more than one location.
Yeah, but which ones are the most critical?
You have to get down into it, and you have to usually pull data, and you have to use part of your 7 basic quality tools to get to which ones are the vital few. Yeah, absolutely. So it's not just gonna be like evident, like you're gonna look at the fishbone and be like, oh yeah. But I mean, you will when you're doing the fishbone, because you have a lot of people giving their input, you're gonna have like, more than likely, this is exactly how it happens. You'll start brainstorming and you'll start putting stuff in categories. And you'll have one person that said, that one time that we lost power and da-da-da-da. So they're thinking of that extreme condition, right? That happened once every 2 years. But it's on your chart because it is part of a cause that causes that effect. But are we gonna spend all that time trying to fix something that happened once every 2 years? Or something that's happening all the time? And that's kind of where you get to it, where you have 100 of them, and then you start brainstorming which one of these 100, which 20 are the big ones. And most people already know what that is, but you really need to have it all in front of you to where you could say, okay, that one really is the big one. We're going to tackle that one first.
I see that
Pulling
now
data.
at night, my dream, when I'm sleeping, I see them.
You know what? You're like me because I dream of work and it's scary. That's how I know I got too much going on. I get stressed about it. So here is a live Ingram example. So this is what I did. I went to the damage e-form and I pulled the entire damage e-form for 2021. So that's all I did. Damage e-form 2021. Pulled it. So this is what I end up with. So first of all, I just did it by branch and I did it by quantity. So sum of the quantity per branch. So first of all, you're gonna see that there's a bunch of stuff here that's not even branches, right? So your data's dirty automatically. That's besides the point. Point of this is Miraloma 7,200 out of 27,000 quantity of defects in your damage e-form. They make up 26%, okay? Millington and Miraloma together is 44. Miraloma, Millington, and Chicago, you guys, you're number 3. All of you together is 56. All right, so either way, we take the top 6 branches. The top 6 branches is 84%. So 6 out of 33 branches. How much is 6 out of 33?
6 minus 33?
6 out of 33. What percentage?
84%.
18%.
18%. So 18% of your branches are causing 84% of your damage. So there's a Pareto principle, and I did nothing. All I did was just pull your data, and
This guy is terrible.
it happened. It's like a thing of nature. 80/20 is always there. And I did nothing to this data. Like, I know if I clean it up, it's probably gonna change it, but still, boom, out of nowhere, first thing I did, 84%. So it's a recurring thing, y'all. All right. Oh man, I got 10 minutes. So how we feel about 5 whys? Just ask 5 why 5 times to get down to root causes.
Ask 5 whys and go to HR office. If we ask an associate 5 times whys, they get start complaining. Why are you asking me that? You are disrespectful to me. It happened to me.
Take this with you. Be like, look, it's part of lean.
Blame Joanna.
Yeah, I would tell
I'll
him.
go.
Email Joanna.
That's fine. What is the important element of the fishbone? Actually, what is the hardest part of the fishbone? The hardest part of the fishbone is actually stating the effect correctly, because a lot of people will not say what the problem is that they're looking at correctly, and you'll end up with all kinds of root causes that you're not even trying to go after. And that's very easy to do. I thought it was in here somewhere.
I'm probably plugging in the feedback into the right category. Plugging in the feedback into the right category, like in the materials, the machine, the measurement.
Sometimes you have it in 5 different places. Honestly, you do. And that happens a lot, where you'll sit there and they'll be like, this is an issue, this is a cause, and you'll write it down. You're like, which category? And they're like, well, it could be that one, and it could be this one. It could be the person and the machine at the same time. If they're not trained right on the machine and the machine's not working properly. So you could have it in both categories for sure.
It can come from food case office, what you call it. Don't give him the sheet to start picking, he's gonna be late. Based on what they pick. They don't have a sheet to pick?
What sheet?
They don't get a form, like how do they do their task? They are picking based on what?
The orders, they give them the
labels.
orders.
Where do they get the labels from?
The food case office.
That's what I'm saying. If there is a delay, that picker is gonna be late.
That's true, yeah.
So
So-
its percentage is gonna go down.
Right. So that is one of the things that you would put on the fishbone. So it would be the shipping office is delayed to give it to them. So then you're gonna go beat them up because they're not at 60, but there was like, I got it 10 whole minutes late, so 10 minutes worth of picking, it's like a 10%, 60, a sixth of a percent. So I'm probably gonna get 50 instead of my 60, but that's because of that delay. And you would put that on the fishbone. And so my next question would be like, how often does that happen? Is it a delay like every day to where your operator every day is delayed 10 minutes because of the shipping office? If it's every day, then we need to go talk to the shipping, what'd you say?
Full case office.
Full case office. If it's happening every day, we need to talk to the full case about.
I'm not saying it happens every day, but I'm saying there are many reasons it could be.
Exactly. No. That's what I'm saying though. But in order to figure out if it's part of the 20 that we need to go after, that's what I would ask. Is it happening every day? If the answer is yes, it's happening every day, that's one of my 20 that I need to go tackle. If it's happening once a month, then it's like, well, these other ones might be more important and that's not part of my 20. But I do want to note it because if it starts becoming more reoccurring, then that's where I need to go focus on. But at least you have everything kind of written down to where you can go and pinpoint it for sure. Oh no, I got 5 minutes. This is good conversation though. I think I can get it done in 5 minutes. So Poka-yoke is my last thing. So, through our journey here, we figured out a problem. We got a problem from our 8 waste. We went out, we process map it. We did our 8 basic quality tools to figure it out. We started doing our root cause. We figure out what the root cause is. Then once you actually know what the problem is, how to fix it, then we look into mistake proofing. So mistake proofing is Poka-yoke. So there you go, another Japanese word for y'all to learn. So Poka-yoke just basically is a automatic device or method that either makes it impossible for the error to occur or makes the error immediately obvious once it has occurred. So those are the 2 things to keep in mind when we're talking about Poka-yoke. So when would we use it? We want to use it whenever you have a human error. So various touch points, you have customer error, handoffs, or significant consequences. So just think about like, how could we eliminate this problem altogether? And here's where we get into it. So how do we do it? So we want to review the process flow chart, and then you review each task for human errors. Well, for errors, human or system. So there are the times where your system can cause the error as well. And then you identify the sources of error. So our goal would be to actually eliminate the error from happening. So think about it. How could you eliminate an error occurring of not counting the right quantities for an order? Completely eliminate it. Could it happen? Can we do it?
If we scan each part of the order, if you scan each part and if the scan doesn't occur, then it doesn't allow you to finalize the order.
That's already part of the process, no?
Do we scan every part?
Do we scan every part?
If you have a quantity of 200 units for the order, it's going to be part of, we can do batch.
No, because you're not necessarily scanning 200. Because it could ask for 200 and you count your 200 pieces.
Depending on the scenario.
Yeah, depending on the scenario.
Okay. So could we though? So serialized numbers.
Individually asking for the 200.
So, okay. So serialized product, we scan every single one. So do you ever have, so does that mean that every order that has nothing but serialized is exactly the right count?
You could still have an error.
How?
Because you have to make sure that the UPC is the same. Because you could have the correct serial length, mixed SKU. I can have 200 pieces, but if I don't visually look at the 200 pieces with the same UPC, the serial number length could be correct. So it's going to take it, even though I put the quantity as whatever. Because I put the quantity as 200.
Right,
and
right.
Then it's going to ask me.
And you scan 200 serial numbers
after you put the quantity in.
But you scan the wrong product
It's
itself.
not going to know because it's only going to read the 200 serial numbers.
Yeah.
It's not going to read the 200 UPCs that you put in.
Right. So in that case, you might not get to eliminate it. So if you can't eliminate, how do we lessen it? So that would be the next thing. So we lessen it by doing the serial numbers, right? So that's one way to lessen just complete error completely. We do that step, and that diminishes it, but it doesn't eliminate it all completely. So there's lots of examples of poka-yoke. So it doesn't have to be anything sophisticated. This here is an example of poka-yoke. So basically all they did is they put a piece of tape across it. So it's not making it impossible for the error to occur, right? Because I mean, you could still put it in the wrong place, but it does make the error immediately obvious. So I know that if I put the 4 over here, my line's not going to be a straight line. It's going to be cattywampus. So it does fall into the poka-yoke category. One that it does eliminate it was the light socket. So I don't know if you remember back in the day, the light socket only had 2 prongs, and you could put it either which way, and it was causing like house fires.
They are still like that in Europe and Middle East.
Is it? Oh, I didn't know
Some
that.
areas are still like that, and they don't have the ground.
The ground, right, and that's why we have the ground, because it was causing house fires, right? That's why there were so many house fires back in the day. So that is an example that makes it impossible for it to happen. You can't put the plug in upside down. All right, and this is my last one, and it's my favorite example, these hardware kits. So this also doesn't prevent you, but it is obvious. So if you're on step 6 and you still have a bolt on step 3, that's an obvious one that you shouldn't be on step 6. You should go back to step 3 and figure out why.
This is not a spare part.
Right.
It has to go somewhere.
I love this. I just thought that was the greatest thing. I actually bought something and it was exactly like this, because like these bolts, use it here and use it there, or no, these little screws, use it in all these steps. But this one, it told you like this, use 4 here and use, 6 there. All right, so that's poka-yoke, and I am out of time. So tomorrow we'll do 6 Sigma, so an hour and a half, and then your quiz at the end. Open book, bring your book, talk to your friends, all that good stuff.
All
right.
Can we call a friend?
You can. If they've taken the test, they might give you the answer. All right, thank you, everybody. We'll see you tomorrow, same time.
Thank you.
That's a good one.
What? I'm not giving you the answers.
Oh, I think this is what you said.
You can phone a friend that's taken the class before.
You understand that she's not friends right now.
Not today, not today. Thank you, see you tomorrow.